Okay, let me start the problem again. Okay, now we are supposed to find this RD. So now it is 0.6 alpha equals 1.8 minus, so this you can straight away write it as 100 exponential minus 6. So that's what I'm doing here. Let me just redo it. So it is now, it is 100. I'm just pressing this ext exponential minus 6, which is actually 100 micro, into 20 divided by 0.18, close the parenthesis, multiplied by, I'm just doing the way how it is there, multiplied by 0.6 x square, because it is 0.6 whole square, multiplied by RD max. So RD max is an unknown value. Let me name it as alpha A. So we have actually fed the equation. Let me start the equation how we have fed it. You can see now it is 0.6 alpha equals 1.8 minus half into 200, which is 100 exponential minus 6, into 20 divided by 0.18. I'm just opening the parenthesis before 20 divided by 0.18, close the parenthesis, multiplied by 0.6 whole square, multiplied by A. So now I will do shift calculate twice. So I did shift cal twice, so I got the value of A as 300. Actually that A is actually RD max. So it is now RD max is 300 ohm. So how do we believe that okay, this answer is correct or not? So now what we can do is we have this expression of VDS. So we have this expression VDS. Let us substitute these values and try to find out whether for this value of RD, which is 300 ohm, whether this VDS comes equal to VDS at. So what is VDS at we are looking at? So of course this should be equal to 0.6. So can I write this now? So this is now VDS. What is VDD? So let me write it here. It is VDD minus ID RD. So if this will be 0.6, if RD, of course, let us find this. So is it not 1.8 minus half Kp W by L VGS minus VTO whole square into 300. If I substitute this RD as 300, this should be equal to 0.6. Let me substitute these values and try to find out whether this equation is 0.6 or not. This equation has to be 0.6, otherwise this RD of whatever we found 300 will be wrong. So what I'll do now, I'll substitute, I'll just edit this equation. So is it not 1.8? So let me write it, 1.8 minus 100 exponential minus 6 into 20 divided by 0.18 multiplied by 0.6 square into 300. This should yield me 0.6. You're getting 0.6, correct? So this is equal to 0.6, meaning whatever RD that we found, if that RD is equal to 300 ohm, then this is 0.6 volt, which will be at verge of saturation. Suppose if the value of RD becomes 200, if it is 200, so then what will be this value? So let me just go and substitute here this RD as 200. If I substitute this 300 by 200, if it is 200 now, what is the value of VDS? So VDS is 1 volt. Can you see now VDS is equal to 1 volt for a RD of 200 ohm. So this VDS of 1 volt will keep my MOSFET well in saturation, because VDS has to be 0.6 if it is at verge of saturation. If VDS is more than 0.6, it is good, so it is deep in saturation. So now RD is 200 ohm, which is less than what 300 ohm. So suppose if you keep RD as maybe 350 ohm. Let me just take it as RD as 350 ohm. If I take this instead of 200, if I take it as 350, if you solve for this, can you see how much is VDS? VDS becomes 0.4. So when it becomes 0.4, it's not in saturation region, because what is the condition for saturation? Your VDS should be 0.6, but how much you're getting? You're getting 0.4. So if RD, if it is more than 300 ohm, so it will be in, the MOSFET will be in linear region. So that's why we say RD should be less than 300 ohm to keep the MOSFET in saturation. To keep it in verge of saturation, it should be 300 ohm. So if it is equal to 300, it is verge. If it is less than 300, it is well within saturation region. So that is the entire concept behind changing the value of RD to keep the MOSFET at verge of saturation. Let us see what is the next problem is. Next problem what we have is this. We are actually asked to find the value of VB to keep the MOSFET at verge of saturation. Now it is the gate to source voltage. What should be gate to source voltage to keep the MOSFET in verge of saturation? Let me just copy that question. Again, it is effectively we have to use the calci so that your time of solving this entire problem will be very minimal. Otherwise, you may have to simplify that mathematical equation and all those things. It becomes very cumbersome. So this W by L is 10 divided by 0.18. We are asked to find VB to keep the MOSFET at verge of saturation. So this is what I have now. Okay, this is the thing. Let me see, is it recording? Yes, it's fine. Okay, now, so again, verge of saturation, we have to find what is, we are asked to find what is VB to keep the MOSFET at verge of saturation. Again, what is, let me not again write the KVL equation at the outer loop. So by writing the KVL equation, which is VDD minus IDRD minus VDS is equal to 0 is the KVL expression, from which I can write VDS is equal to VDD minus IDRD. So what is the verge of saturation now? Since this is not known, I can still write what is the verge of saturation, because at the verge of saturation VDS at the verge of saturation VDS is equal to VGS minus VTH. But what is VGS? VGS is VB, simply read as VB only, VTH. So in case of VDS, you write it as VB minus VTH, So I will write it as VB minus VTH is equal to VDD minus IDRD. So now let me expand this ID. So I will rewrite this. This is VB minus VTH equals VDD minus half into KP W by L VGS. Now VGS is actually VB. Shall I write it as VB minus VTH whole square into RD? Now I don't know this. Sorry, this is VB minus 0.4 equals 1.8 minus half into 200 micro into 10 divided by 0.18. VB is known, non-known, 0.4 whole square. So how much is RD? It is 1.5K. So we know everything in this equation except this VB. See here, VB is the only unknown in this. So let us not solve this mathematical problem. Let us feed the equation as it is onto calci and get the value of V. So I hope you got, okay, why did we write this VDS as VB minus VTH? So this is actually VGS minus VTH, which happens to be the verge of saturation condition. So now it is, this is unknown parameter, it is now, so let me, for clarity I'll write it here. It is alpha A minus 0.4 alpha equals 1.8 minus 100 exponential minus 6 into 10 divided by 0.18 multiplied by, it is alpha a minus 0.4 whole square multiplied by 1.5 exponential 3. So if you just trace this entire equation what we have typed, so what we have typed is, if you can see, it is 0.4, sorry, a is VB minus 0.4 equals 1.8, which is VDD, minus half into Kp is 100 micro, which is 100 E minus 6 multiplied by W by L, which is 10 divided by 0.18. Of course, we are not writing micro here. This is actually micro and micro. So this micro get cancelled. That's why we are not writing W by L. In case of W and L, we are simply writing it as 10 and 0.18. And it is alpha a minus 0.4 whole square into 1.5 exponential 3. Now let me solve for shift calculate twice. I'll get the value of VB. So I got the value of VB as 0.808 volt. This is one value of VB. So since it's a quadratic equation, there can be other value of VB. So let me try to find the other value of VB. So for that I will say equals, and a question mark will come. I'll write it as minus 1, again equals. So a question mark is minus 1. Let me solve for this. So I'm trying to find the other root of this alpha a, that is variable. So that is coming out to be 0.128. Let me again repeat. We actually had 0.808 as one of the answer, but this equation is a quadratic equation. So we know that mathematically, if the order of the equation is 2, we will going to get two values of VB, two values of that unknown parameter. So we know the one value of VB. Let us find the other value of VB. To find the other value of VB, what we actually did was, we said equals, a question mark came, then when we actually put minus 1 and then again equals. So a question mark is equal to minus 1. You do shift cal, you'll get minus 0.18. Suppose that this itself is the first value, then how to find the second value, how to find this value, how to get this value now? In such case, now say equals, press some positive value. Now it is 1 equals, a question mark is 1 now. So now do shift cal. You will get the other value, 0.18. Can you see? You got this value. So now we got this as well as this. Out of these two, which is a valid answer? So electrically only one is a valid answer, but mathematically both are true, both are correct. But electrically you cannot have a base, okay, VGS, which is negative voltage. So this is not a valid answer. So VB of 0.808 is the valid answer. Your gate VGS should be equal to 0.80 volts, so that MOSFET remains in saturation region. So now, how do we verify this? So what is, suppose if this is 0.808 is your VGS, then how much is VDS sat? So VDS sat happens to be VGS minus VTH, which will be, for this VGS it will be 0.408 volt, correct? It is 0.808 minus 0.4, it is 0.408. So now this should be the voltage that I'll be getting if I substitute this VBS 0.808 in this equation. So what I'll do now, so let me solve for this. Let me find this VDD minus half Kp W by L. Now what is this VGS now? VGS is 0.808 minus 0.4 whole square into 1.5K. So let me substitute this as 1.8 minus so and so. So let me just do that. So it is now 1.8. I'm just substituting this value. Now this is just a verification. Of course our problem is already solved here. So we just want to verify whether I will get, upon solving this, will I get 0.408 or not. So is it not 1.8 minus 100 exponential minus 6 into 10 divided by 0.18, close the parenthesis, multiplied by 0.408 square. That's what is VGS minus VTH whole square into 1.5 exponential 3. If I solve for this, don't you have it as 0. How much is it? 4.128. How much you expected? We actually expected 0.408. Why there is a slight mismatch? So you might have noticed that when we actually got this value of VB, we actually took only 3 decimals. Suppose if you take all the decimals up to 10 decimals, and if you substitute here, then this value will certainly tally with this. How much is the difference between these two? Even though it looks big, but how much is the difference? It is 408 millivolt. How much is this? This is 412 millivolts. Hardly 4 millivolt difference. Sorry, it is how much? Is it 4 millivolt only? Yes, it is 4 millivolt only. It is 408 millivolt. This is 412 millivolts. It's hardly a difference of 4 millivolts. It is due to this truncating the value of VB. So this value of VB, which is 0.808, if you keep this here, if you keep this value as 0.808, the MOSFET will be at verge of saturation, because for this value of VGS, the MOSFET will be at the verge of saturation with the voltage here as 412 volts, which is very close to saturation, which is at the verge of saturation. Got it now? I hope you got what is this difference is. So there's a slight difference. Don't say that this is wrong answer. This is certainly a correct answer, because we slightly, suppose if you take up to 3, 4, another 2, 3 decimals, then this will be perfectly, even that difference of 4 millivolt will also be not there. Okay, hope you can understand this concept. So here in this entire case, we actually found the value of VB. Most importantly, use of calc is so important. Otherwise, you would have spent a lot of time in simplifying this equation, which is not a part of your electrical analysis. So electrical analysis is writing this and all these things. This we can effectively utilize the calculator, use this alpha A and alpha equals concept, and then start doing the simplification quite easily. So let us see the third question. What we have the third question. Now it is we are asked to find what is the W by L to keep the MOSFET at verge of saturation. All other parameters are given. Again, it's the verge of saturation. So let us try to find out what is the solution for this, or how do we find the solution for this third problem. So let me just write the third problem. I have again RD, and there is a bias voltage which is already fixed, and I have a NMOSFET with a W by L of, so I have a RD of 1.2 kilo ohm. So there is of course I'm supposed to find what is W by L. So VB, that is VGS, is given as 0.8 volt. So please don't get confused. VB is actually bias voltage, and VDD is 1.8 volt. So we are asked to find W by L for keeping the MOSFET at verge of saturation. So let me again go back to this. From our KVL, Kirchhoff voltage law for the outer loop will give you VDD minus ID RD minus VDS equal to 0, from which I can write VDS is equal to VDD minus ID RD. So since you are looking for W by L which will keep the MOSFET at verge of saturation, again this is W by L max, because if W by L exceeds beyond that, MOSFET enters the linear region. So we will write it as W by L max. So now this for when W by L is equal to W by L max, then VDS happens VDS sat. So this is VDS sat, which is equal to VGS minus VTH, which is equal to VDD minus IDRD is now it is half Kp W by L max into VGS minus VTO whole square into RD. So let me just substitute the values. So I have this VGS as 0.8, this is 0.4, and it is now 0.4 is equal to 1.8 minus 100 micro. WBL need to be found. So this is WBL that I am trying to find. VGS minus VTU I can write it as 0.4 whole square, and RD is 1.2 kilo ohm. So now this is the value what you are supposed to find. So use this. This is 0.4, alpha equals 1.8, this, and so on. Let me just do that. So it is now 0.4 alpha equals 1.8 minus 100 exponential minus 6 into, this is to be found. Now you put it as alpha A multiplied by 0.4 square multiplied by 1.2 exponential 3. So we have fed the equation. Let me just have a look at the equation what we have fed. So this is actually equal to 0.4 alpha equals 1.8 minus half kp, that's what is 100 micro, into alpha A, which is the unknown parameter, and 0.4 square VGS minus VTH multiplied by 1.2 exponential 3 is 1.2 kilo. Solve for shift calculate. So you got the value of W by L max as 72.91666. Okay, let me write these numbers so that we get a proper answer. So now, because let us verify that also. So now this is W by L. Now if the W by L is 72.91666666, you will going to get the MOSFET will be at verge of saturation. Then what do you mean by verge of saturation VDS? Then VDS will be equal to 0.4. So this is the answer. So we are having the answer of W by L should be equal to 72.916666 for keeping the MOSFET at verge of saturation. Let us verify whether we get the value or not. So let us use this equation to find what is VDS then. Is it not 1.8 minus what is ID now? It is half kp. W by L is now, it is 72.916666. How many 6 are there? 5 6 and another 7 multiplied by 0.4 whole square into 1.2 kilo ohm. So this should actually give me 0.4. This should actually give me 0.4. Let me just check it out. So it is now 1.8 minus it is 100 exponential minus 6 into 72.91666667. No, just for fun we are doing it. That is these values. Otherwise 92.9 would have been sufficient. Into 0.4 square into 1.2 exponential 3. Are you not getting this value? We are expecting 0.4. How much you are getting? You are getting 0.399999. So many 9s. So is it not equal to 0.4? So that's how close this is. So whatever value of W by L we found, so it is 72.9. Suppose if I just go back and substitute only 72.9, so let us see what happens. So let me just delete those. Okay, so many 6 were there. Let me just delete that. Let me start deleting from this one. So delete. Okay, I have deleted all the values. So I have written it as 72.9. If I solve for this, so I got the value as 0.4003, which is equal to 0.4. Now how much is the difference? You hardly have a difference of this is actually 4, okay, 2 zeros. Is it not 400.32 millivolt? How much is the difference from 0.4 to 0.40032? It's actually 0.32 millivolt difference. That's what is the thing. So and this is not required at all, but so just have a confidence that okay, whatever value that you found is matching with the expected answer, we're just doing it. So this is not required to be done. So W by L max should be 72.9, or W should be 72.9, so that MOSFET is at verge of saturation. I hope it's fine now. Let us find the fourth problem. Now it is the VDD. What should be VDD to keep the MOSFET at verge of saturation? Now, so far we saw RD should be RD max, VGS should be VGS max, and WL should be WL max. So your VDD, sorry, RD, WL and VB were supposed to be less than whatever we found to keep the MOSFET at saturation. That's what I want to say here is, here in this case, here in the previous case of this, we said RD has to be less than 300 ohm to keep the MOSFET at saturation. Here we said the VG or VB should be at 0.808 to keep the MOSFET at verge of saturation. If you keep more than this, then this voltage will be not the saturation voltage. This will become a voltage which will keep the MOSFET in linear region. So this is the maximum voltage you can keep. Then we found this is the maximum WL you can keep. If you keep more than this WL, even if you keep the WL as 75, the MOSFET is in linear region. Now let us find in the fourth problem what should be the value of VD or VDD to keep the MOSFET at verge of saturation. So now the problem what we have is, let me copy that. So now I have the VB is given as 0.7, VDD we don't know, this is 800 ohm is your RD, this is WL is taken as 10 divided by 0.18, so and so. So this is the equation what I have. This is the circuit diagram what I have. So we are asked to find what is VDD to keep the MOSFET at verge of saturation. So can I write VDS? So what is VDS now? So VDD minus ID RD minus VDS is equal to 0, from which I can write VDS sat is equal to VDD, or first let me write as VDD minus ID RD. Now VDD will not decide my ID, so now I will write this as VDS sat is equal to, then VDD should be minimum. If VDD is more than what we found, then the MOSFET is certainly in saturation. If the value of VDD is kept less than what we find, then the MOSFET is in linear region. So that's why this is VDD minimum minus ID into RD. So what is VDS sat? VDS sat is VGS minus VTH. VGS minus VTH is equal to, this is not known, this is not known, this is for verge of saturation. ID we know, it is half Kp W by L VGS minus VTO whole square into RD. So let me substitute the values what I have. So is it 0.7 minus 0.4 is equal to VDD I don't know, minus 100 exponential minus 6, this is 10 divided by 0.18, and this is 0.3 whole square, and this is 800 ohm. This is 800 ohm. So these are the values that I have. So let me just feed this over here. So this becomes 0.3 because 0.4 minus 0. Okay, this is 0.3 alpha equals VDD is don't know, unknown parameter, alpha A minus 100 exponential minus 6 into 10 divided by 0.18 multiplied by 0.3 whole square into 800 shift cal. So I got the value of VDD minimum as 0.7. So it is now 0.7 volt is VDD minimum. That is, VDD should be minimum 0.7 volt to keep the MOSFET at saturation. So what we'll do is, we'll substitute 0.7 here and try to find out whether this is 0.3 or not. So now let us write this as VDD minimum minus ID RD should be equal to VDS sat, that is equal to 0.3. So how much is VDD minimum? It is 0.7 minus 100 exponential minus 6 into 10 divided by 0.18, close the parenthesis, multiply 0.3 whole square into 800. If I solve for this, I should get 0.3. Are you getting 0.3? Yes, I am getting it as 0.3. That means the VDD, if it is 0.7, then 0.7 minus ID into RD will be 0.3. So MOSFET is at verge of saturation. Suppose if you keep the value of this less than 0.7, suppose let me just keep it as 0.6. Let me keep it at 0.6. Suppose if you keep the value of VDD less than whatever we found, then what is this? It has become 0.2. So MOSFET, because this should be 0.3, no? So then this has become 0.2. So MOSFET is not in saturation. So let me keep the voltage 0.8. Let the VDD be, okay, let the VDD be 1.8. So if the VDD is 1.8, will it be in saturation? Let us find out. 1.8. So this is what I substituted. Instead of 0.7, I kept it as 1.8. Let me see what is the value. How much is VDS now? VDS is 1.4. So with this VDD as 1.8 volt, your VDS is 1.4 volt. Is the MOSFET in saturation? You are supposed to have only 0.3, but you have 1.4. So this is well in saturation. Meaning to say, VDD, if it is anything more than 0.7, MOSFET is in saturation. So VDD has to be minimum 0.7, so that MOSFET is at verge of saturation. If it is less than this, it's in MOSFET is in linear region. If it is more than this 0.7, then naturally it is in saturation region. So this is why we wrote it as VDD minimum. So this, of course, maybe while solving the problem, you can simply write it as VDD, and you can say that VDD is equal to 0.7 for keeping the MOSFET at verge of saturation. Okay, let us move to the next one. Next, we are asked to find the value of ID. So what is the value of ID now for this fifth problem? So it is not to keep the MOSFET at verge of saturation, all those stuff. So you are basically asked to find the value of ID, that is drain current. Let me write that equation, circuit diagram what I have. So this is the circuit diagram. VDD is equal to 1.8 volt, RD is equal to 800 ohm, W by L is 15 micro divided by 0.18 micro. It's actually micro. It is written as simply 15 by 0.18. You cannot think of that much large amplitude, large dimension. Now this is, you are asked to find ID. So let me find out what is ID is. So this is the problem what we have. We are asked to find what is ID. So we know that since drain and gate are shorted, MOSFET is in saturation region. So let us write the saturation region equation, which is half Kp W by L VGS minus VTO whole square. So we are asked to find what is VDS sat. But in this, I know Kp, I know W by L, I know VTO or VTH, but I don't know what is VGS, because this is what is VGS. So is this is drain, is this is gate, is this gate and drain voltage same? So can I write VGS as equal to VDS, because this G is replaced by D, because G and D are same. So I can write VGS is equal to VDS. But what is VDS? VDS from this outer loop, I can write it as VD minus IDRD. So substitute this VGS as VD minus IDRD, solve for it, you will get what is ID. So shall I now write ID is equal to half Kp W by L VDD minus IDRD is my VGS minus 0.4 whole square. So now this is the unknown value. This is 100 micro. This is 15 by 0.18, and this is 1.8 minus that is ID into how much is RD? It is 800 ohm minus 0.4 whole square. Of course, only unknown is ID here, so all other parameters are known, so solve for ID. Here also I'll get two values of ID because it's a part of quadratic equation. So you may question, sir, why we didn't find the two values over here. So in case of VDD also, no question of two values because this is not a part of this quadratic. So this is not a part of quadratic. Even in case of RD, we didn't find the second value because it's not a part of quadratic term there. Even in case of W by L, we didn't find, where is W by L? So we actually, of course, in case of V, okay, in case of W by L also we didn't find. Let me just show you that. Where is that? Look at this. Okay, let me see. W by L we have. Okay, here. Can you see? We didn't find two values, so it's only one value. So only in the case of VB we found two values. So only in case of VB we found two values. You can see VB we actually had two values, which is a part of this quadratic. It comes under it comes under that quadratic thing. So that's what is. So that's where you are finding this. So now we are asked to find what is ID here. So since ID is a part of this quadratic, I am going to get two values of ID. I have to find two values of ID. So now shall I proceed now? If I proceed with this value of ID, let me just okay, fine. This is elimination was a bit low. Now I'm supposed to find this ID value. So start with okay, let me just write alpha A, alpha equals, that's what is this, alpha A, alpha equals 100 exponential minus 6 into, open the parenthesis, 15 divided by 0.18, close the parenthesis, multiplied by 1.8 minus, this is again alpha A into 800 minus 0.4 whole square. That's it. Shift cal. I'll get one value of ID, which is 2.424 milliamperes. This is 2.424 milliamperes is one value. How about the other value? To find the other value, I will say equals, maybe say minus 1 equals shift cal. I'll get the other value. So other value is 1.26 milliamperes. So this is other value. Suppose if this is the value, how to get the other value? So it is, let me say equals a question mark. Let me say it as simply 10 exponential minus 3. Let me give some 10 milliampere equals shift cal. I'll get this 2.42. You can see I got 2.42. In order to get this value, I will say again equals, I will say 1 exponential minus 6. I'll give a very small value. Equals shift cal. Then I'll get this 1.26. What I mean to say is, if you want to find the other root, it is not always necessary to give minus 1, or it is not always necessary to give plus 1. So you have to give a very small value, which is 1 micro, and when I give a small value, it picked this. When I give a bit larger value, it actually picked this. Actually what happens is, so assume that this is a line where the two roots lie. So this is, assume that okay, there is one root here. So there is a root 1, there is a root 2. When I say root 1, root 2, it has these two values. So assume that when you did shift cal for the first time, when we actually do shift cal, can you see here, when I do shift cal, can you see that a question mark comes here? A question mark comes. In this a question mark, if the value that is sitting is a large value, suppose if the value sitting here is something like 3, if the value that is sitting is 3, is this 3 is closer to this? So when I do shift cal, when I do shift cal, it will pick this value, which is the value which is 2.424. So when the default value a question mark was equal to 3, it picked this value, which is this 3 is closer to this because it is 2.42 milliampere. Now if I want to find the other value, let me just do equals a question mark. Let me give some very small value, which is nothing but 1 exponential minus 6. So this, I know that this is 1.26 milliampere. So the value that I have given is 1 exponential minus 6, which is 1 micro. If I solve for this now, if I solve for this, it will actually pick this closer value, which is nothing but this. So now we have to give two extremes or two values, so that one should be closer to this, one should be closer to this. The one which is closer to this root, it will pick that root. The one which is closer to this, it will pick this root. So that's why it is either. Now we have two currents. So ID is equal to 2.42 milliamperes or 1.26 milliamperes. So out of these two, which is correct now? Which is correct? Let us find out which is a possible answer. Suppose if 2.42 milliamperes flows through this MOSFET, then what is VDS or VGS? Is it not VDD minus IDRD? Is it not VD minus IDRD? So how much is that VD minus IDRD would be? So is it not 1.8 minus 2.42 milliampere multiplied by 800? If you substitute that, is it not 1.8 minus 2.42 exponential minus 3 into 800? Can you say, has it become minus 0.136 volts? So your VDS or VGS has become negative. VGS has become negative, meaning that this is not a possible current that would flow in this circuit. Why? Because we actually had two currents. We are trying to verify which one is a correct answer. When you actually substituted this current and found what is VGS, before we say whether this is correct or this is correct, I had to do this. So VGS is equal to, or VDS is equal to VGS is equal to VD minus IDRD. If you substitute ID as this value, you got it as negative. So this is not a possible answer. Let us substitute this and try to verify whether it's a correct answer or not. So now instead of 2.42, let me write it as 1.26 milliampere. So it is now, I just go back here, this is now 1.26 milliampere. If you solve for this, how much is VGS? So it comes out to be 0.7972 volts. It is 0.792 volts. Suppose if you substitute, now let us try to verify whether this much current flows or not. So how much is ID actually equal to? Is it not half Kp W by L VGS minus VTO whole square? How much is VGS we got? We got it as 0.792. Let me substitute that. It is half into 200 micro into 15 divided by 0.18 multiplied by 0.792 minus 0.4 whole square. This should give me 1.26 milliampere. This should give me this much. So let me verify. So what I'll do, it is 100 exponential minus 6. Now these are all extra things to confirm ourselves whether this found value of VGS, will it give that much current or not. So it is 100 micro into 15 divided by 0.18 multiplied by 0. Okay, this is actually 0.392 whole square. How much is the current? Don't you have it as 1.28 milliampere? Again, why this difference of how much is the difference? The difference is 0.02 milliampere. So why this difference is? Again, because of not considering all decimals of this VGS. So that's what is, it's hardly 0.02, it's actually how much, 20 microampere difference, which is not a huge thing. So this way, when you get two values of ID, how to choose a proper one is, we have to find whether this VDS is a valid or a feasible answer or not. So So VDS negative is not a feasible answer, so you cannot consider this. So ID is now equal to 1.26 milliampere. If you do simulation, you'll get exactly this much correct. Fine. Let us go to next problem. Let me see whether this is going on. Okay, it's fine. It's gone almost 45 minutes. Okay, bear with me. Okay, now last problem is you are asked to find the value of RD to keep the MOSFET at verge of saturation, the sixth one. So now this is a bit lengthy one, so it is a bit involved. Let us try to find what is RD to keep the MOSFET at verge of saturation in this sixth problem. So let me copy that question. I have a RD, there is a MOSFET, there is a RS also underneath it connected to this, and I have a RG which is of 100 kilo ohm. This is VDD which is 1.8 volt. RD is equal to, of course we are supposed to find to keep it at verge of saturation. RS is actually 200 ohm. W by L is 10 divided by 0.18, and this RG is equal to 100 kilo ohm. Okay, fine. So we are asked to find the value of RD to keep the MOSFET at verge of saturation. Okay, this is the problem what we have. Since we are asked to find the value of RD, so again let us write the KVL here. So what is KVL? KVL is, you can write it as VDD, which is starting from the loop, minus ID into RD minus VDS minus ID into RS equals 0. This is my expression. So what is actually VDS now? VDS is equal to VDD minus, I can take out ID common factor, write RD plus RS. RD plus RS. So you are looking for RD max, so this becomes VDS sat. So now can I write this as VDS sat is equal to VDD minus ID. This is now RD max. This is the maximum value of RD to keep the MOSFET at saturation when VDS becomes VDS sat plus RS. So what is VDS sat now? It is actually VGS minus VTH is equal to VDD minus ID into, again, RD max plus RS. But what is ID? Let me again write, this is VGS minus VTH is equal to VDD minus half Kp W by L. Because you have to keep it in saturation means you have to write the saturation equation, which is VGS minus VTO whole square into RD max plus RS. But what is VGS? We don't know what is VGS, it's not directly given. So VGS, as we know, this is gate, this is source. So what is actually VGS is equal to? VGS equal to actually voltage at gate minus voltage at source. So what is the voltage at gate here? So what is the voltage at gate here? So it is nothing but the VGD minus the drop across RG. So how much is the, suppose if you consider this as IG, so shall I write this VG is equal to VDD minus IG into RG? This is what is, you have a VDD here, so there is a drop, and drop VDD minus this drop is nothing but your VG, that is voltage at gate. But we know that the current that is going into the gate is 0 because it's an insulator. So this current is 0. This current is 0. When this current is 0, VG is equal to VD. So VG is equal to VDD. So what is Vs here? The voltage at source. We have a current of ID flowing here in the drain. The same current will flow out of the source also. So it's actually ID which is leaving the source. So what is then the voltage at source? It is nothing but ID into RS. So Vs is ID into RS. So now what is VGS now? VGS is equal to VDD minus ID into RS. So wherever VGS is there, replace it by what? VDD minus so and so. Correct? So can I now replace? So now what we'll do is, first let us find what is VGS from this equation. So here what is unknown is, so what we'll do is, we'll just find what is this is, because what we are asked to find is, since we are asked to find what is RD max, we don't know this also, so what we'll do is, first, okay, shall we find what is VGS? So can we find what is ID here? What is ID is equal to, is it not half Kp W by L VGS minus VTO whole square? So what is ID? This is ID, half Kp W by L. How much is this? Okay, VGS is equal to VDD minus ID into RS minus VTO whole square. So in this, do we know everything except ID? We know this except ID. So from this I'll get ID. I'll get what is ID is. So what is ID now? Let me use calci. Okay, why we are trying to find ID is because in this equation you don't know. Okay, if you substitute VGS as VD minus ID, so ID is unknown. Again, ID you need to replace it by this, so it's a never ending equation. That's why I need to find what is ID, so that I can able to find out what is RD max. So now what is ID now? So now it is 100. Okay, let me write, because ID is there on the either side. I'll actually get two values of ID. I need to choose a proper one. So it is alpha A, alpha equals 100 exponential minus 6 into, how much is W by L? 10 divided by 0.18 multiplied by open the parenthesis 1.8 minus alpha A into 200 minus 0.4 whole square, shift cal. I get one value. So the one of the value is 3.2 milliampere. The other value is equals minus 1 equals shift cal. The other value is I'm getting it as 3.2 milliampere as the value. So let me just find out. It is okay, I'm getting a value of ID as 3.2 milliampere is the only value that I'm getting. So let me find the other value. So let me say equals, okay, shift cal is, okay, I got 3.2 equals 1 equals shift cal. Let me find the other value, which is a larger value. Okay, the larger value is, how much is this? This is actually 15.29 milliampere. Actually we got this as one of the value. Other value I was trying to find lesser than this. I give actually -1, try to find a lesser value. Actually you don't have a lesser value less than 3.2 milliampere. It's actually you have a higher value. So that's why I gave a question mark a larger value, which is 1. I got it as 29 milliampere. So naturally this much current will not flow. So 3.2 is a valid answer. So now if you come here, so what I'll do now, so I will write what is VGS. So VGS is equal to, I can find now what is VGS. So what is VGS here? VGS is equal to VDD. Okay, let me write it is VDD minus IDRDs. It is 1.8 minus 3.2 exponential minus 3 into 200. So this is 1.16 volt is the VGS value. So let me substitute here. Is it not 1.16 is equal to, let me use this directly. Because I already know the value of ID. Is it not 1.8? How much is this? this is 3.2 milliampere, this is RD max, this is RD max plus 200 ohm. So this is the only unknown, this is the only unknown. So now what is the value now? It is 1.16 alpha equals 1.8 minus 3.2 exponential minus 3 into alpha A plus 200 close the parenthesis, shift cal. Okay, what I'm getting is, okay, I have to find why I'm getting it as 0 means because that is equal to this, so you're going to get it as so and so. So in order to find RD max, let me just find out. So if it is equal to 300, so you have it as, so I have a value of ID is equal to 3.2 milliampere. This is VGD. Let me go back here and try to find out. What is that we are asked to find? So let me just try to find. Okay, here there's a solution for this. We have actually solved it. Let me just go back and see what we have done there. Okay, this is what is that value of ID. So that's what, okay, we had an answer of ID is equal to 3.2 milliampere as well as 15.2 milliampere is not possible. That's what we saw in our problem also. Then using this, so we are trying to find the value of RD max. So RD max is actually okay, now this is what you're supposed to find. What we actually did there is okay, here okay, so let us do it now here. So what we did, this is VGD minus ID RD into okay, let me just tell you, okay, what is the issue that we had here. Let me just show you what is the mistake that we have done. Actually what I substituted here is, this is actually VGS, correct? This is VGS. So what I was supposed to substitute is VGS minus VTH. So I actually substituted VGS itself over here. Actually VGS minus 0.4 I have to do. So this is actually VGS, no? This is VGS. So that's why I was getting it as 0 as the answer. So it is, what is VGS now? It is 1.16 minus 0.4 is equal to this. So now if I just do this, it will come. So is it not, this is the only mistake what we have done. So VGS is actually equal to 1.16. Here I would have substituted VGS, in place of VGS it would have been 0.16 minus VTH is 0.4. So if I solve for this, so what is this now? 1.16 minus 0.4 alpha equals, this is what the expression is, 1.8. So it is 1.8 minus 3.2 exponential minus 6 into alpha A is my RD max plus 200. If you solve for this, you'll get 125. Okay, what is it has happened? Okay, what is actually VGS? One second. Okay, one second here. This is VDS sat now. What is VDS sat is equal to? It's actually equal to VDD minus VDD, okay, VDS equal to VDS sat, which is, just go back here and try to find out. VDS sat is equal to VDS is, so VDS sat is VGS minus VGS. This is VGS minus VTH. VGS is this. Okay. This is correct. So can I write this as, instead of substituting it as 1.16, maybe this may not be 1.16. Let me write VDS. Okay, let me just let us have this clarity here. Nothing to worry. What is VDS sat? VDS sat is equal to VGS minus VTH. So VGS is actually VDD minus ID into RS minus VTH equals 1.8 minus, this is what, VDD of, okay, which is VDD minus ID into RD max plus RS. If I solve for this, I know everything except RD max. So I know what is VDD. How much is this VDD? So it is 1.8 minus 3.2 exponential minus 3 into 200 minus 0.4, close the parenthesis, alpha equals 1.8 minus 3.2 exponential minus 3 into, open the parenthesis, alpha a plus 200, close the parenthesis, shift cal, you got 125. Let us find out what is the mistake. The mistake may be over here. So how much, this may not be 1.16. Let me just find out. Okay, this is the RD max. RD max should be 1.25 ohms, so that MOSFET is at verge of saturation. Let me find out this. So how much is this VDD? It's 1.8 minus 3.2 exponential minus 3 into 200. It's actually 1.16. That's what is 1.16. 1.16 is this minus 0.4, 0.76. Okay, 0.76. Sorry. Okay, 0.76 alpha equals 1.8 minus 3.2 exponential minus 3 into alpha a plus 200. I should get same answer, 125. I'm getting 125. So I don't know why I got some different answer. This is still correct. This is, let me redo this. So if I solve this also, I should get 125. Maybe while editing I made a mistake. Is it not 1.16 minus 0.4 alpha equals 1.8 minus 3.2 exponential minus 3 multiplied by alpha a plus 200, close, shift cal, you are getting 125. That is correct. So this is perfectly correct. So why okay, in the earlier case I substituted this entire thing as 0.16, which was 1.16, which was wrong. Then we substituted this voltage as 1.16 minus 0.4. then okay, while solving I didn't get 125, maybe some mistake in my entry to the calculator, but now if I solve it, so I'll get it as 125 ohms. So this is the maximum value of RD. If you keep the value of RD beyond 125, then MOSFET goes to linear region. So this way, now this is not at all difficult. So here, since we didn't substitute that value of VGS minus VTS properly, we had a mess up here. Otherwise, this is a straightforward question where you can able to find. Hope okay, this is going to help you in understanding the MOSFET problems. Thank you.